Okay, we're back. Next morning. Um, the goal right now is to just do 3 problems, 30 minutes max to solve them until we get a tick for string problems. Let me plug in my laptop because I need to charge it while I'm doing this. All right. LeetCode has a cool feature where you can just randomly pick a problem, which is pretty cool. I might just do that, but I mean, you can start from anywhere. The point is just to pick one and go with it. They're all easy problems, relatively speaking. They're all easy. So in terms of frequency, Roman integer is frequent, meaning problems that appear in real interviews. This appears in real interviews all the time. 99.48% of interviews reported Roman integers. So let's look at that one first. Let's take a look. And I used to have it handy, but I have a system that, I borrowed from another course on how to appropriately solve problems. So I think the first thing you do is restate the problem in your own words. Then you ask for clarifying questions. You define test cases and use test cases to come up with your first solution. And then you code up the solution and then optimize. So it's like a 6-step process. Then 8-step kind of talk about, and 7th or 8th step talk about the time and space complexity as well. So here we go. 4 million entries, 2.3 million accepted. Ooh, like off the first time. Anyway, Roman numerals are represented by 7 different symbols: I, V, X, L, C, and D, and M. Symbol I is 1, 5, 10, 50, 100. Okay. So, for example, 2 is written with 1, 1, or I. Just 2 1s added together. 1, 2 is written by XII, which is simply 10 plus 2, okay? 27 is XX, 5. XXVII, which is 10, 10 plus 5, 25 plus 2 is 27. Roman numerals are usually written largest to smallest from left to right. However, the numeral for 4 is not III, it's IV. Because the 1 is before the 5, we subtract it, making it 4. The same principle applies for the number 9. It's IX. So there are 6 instances where subtraction is used. I before V. I is placed before V and 10 to make 4 and 9. X before L to make 40 and 50, or 40 and 90. And C before D to make 400, because C is 100. Or before M to make 900. Otherwise, it's after. Okay. So we take a number and we turn it into valid Roman numeral math. This is an easy problem. Oh my God. Amazon, Adobe, and Apple asked this question. Interesting. What are the constraints? No hints. So s.length is 1 to 15. So 15 digits in the number. S contains only characters I, V. Oh, wait, what? Oh, I'm stupid. Sorry. Given a Roman numeral, convert it to an integer. Okay. Given a Roman numeral, convert it to an integer. So the timer is 30 minutes. 30-minute timer. And the goal is to just try to solve it in 30 minutes or less. 30 minutes has passed. Done. Just cut out. I need chapstick. I lost my chapstick and I hate it. Okay. Again, these videos have no format, no editing, no script. I'm just hitting record and letting my mind spit things out as I go along. Okay. You can add more test cases if you want. Thank God. This adds the classic III. This adds the buildup of LV, right? And then here's some subtraction stuff. C coming before an M, I coming before a V type of thing. Which are good. Those are good test cases. Oh, weird. If you want to write more code. Okay, cool. Anyway, let's see here. Okay, so let's focus on the 3, right? So given I, we know that I relates to 1. So because we know that I is equal to 1, if we see 3, we know that we can't use 1,000, we can't use D for 500, we can't use C for 100, L, X, and V, because the number we have is less than all of that. So we have to use an I. So if we get the I, or we're getting a Roman numeral, we're converting it to an actual number. Okay. And there are 6 cases where an I, X, or C before V, X, L, C, or DM would mean a subtraction. Okay, so in the I case, because the I did not become before a V or an X, this is a 1, not a subtraction. This is an addition. So maybe we have a dictionary where we say, here's a lookup, I is equal to 1, or I maps to 1. Then we'd say, if we get an I, we'd say like, you know, we're going to have to iterate over the string anyway. And we'll say like if the next one is not V or X, this is addition. Otherwise it's subtraction. So because we look next and it's an I, then we know that it's addition. And since so just for this pairing, right, the first 2 I's, index 0 and 1, we know this addition. So we can say 1 is equal to 1, 2. Then we look at the next I, which does not, the next character is null. So we know that there's no next character, meaning that this is addition as well. So it becomes 3. Problem solved. So how do we code that up? Well, a simple solution would be to iterate over the string. Since we're on I, if the next character in the string is not a V or an X, it's addition. And we just do a lookup. So since it's a class, we can technically just use the lookup somewhere else. So we just say like Roman to int mapping. And we're gonna direct dict assignment anyway. And this is an instance of the class. The string is an I, it maps to 1, right? Returns an int. So we get S and we say for, Roman in S. Well, actually, we need to look up the next character. So we'd have to enumerate S. We get the index and the Roman character. So we'd say, what do we say? We don't know whether to add or subtract unless we know what the next character is. So we'd say cur is R, right? Then we'd say next sure gets, S at I plus 1. And it's funny because that might even give a key error. So how do we avoid that? I don't know. I don't have no idea how we avoid that. Keep track of a running sum. Just to get rid of that right squiggly. I have terminal sum. This is happy now. Current next, and then we'll say, this is gonna throw a key error, isn't it? Or like an add bounds error. If it throws an exception, pass. If it throws an exception, we know that this is not, there's nothing next, so we can just add, I guess. Maybe. Otherwise, next gets, you know, let's get done. So say if next R equals what? V or next. Or next R equals X, then we'll be subtracting, right? Else something goes in there, right? So we know in the else case, oh, I mean you can use a double nested loop, right? Take the first character and then modify it based on what comes next. The pairings, yeah, it's gonna get kind of weird. But this is our solution to solve the first case, just I. And so we're gonna subtract here, right? Say sub. We'll just do addition, and we'll say that final sum, you know, plus equals Roman mapping at R. Final sum plus equals Roman mapping. Okay. And we can store these numbers anyway. That maps to a 1. Maybe a while loop is better here. So I think a while loop is better here, right? Potentially. Like while we have, like we're iterating, we're gonna look at each character, but the for loop is a little, yeah. I think one thing I've learned is that when you have the potential to look at like null, when you're running this, a while loop is probably better. When you're running stuff like that, a while loop is better. So we'll just say like, we'll say pointer, get 0. We'll say while. So taking care of that piece of code. And we can say okay, so we're gonna add the there's occur, right? Final sum plus equals Roman to int mapping cur. So if the next is an V or an X, then we want to subtract whatever that would be, right? Which is basically, now we have two options here, right? We could map the IV, because we know that's for sure going to be 4, or IX, which is for sure 9. So for example, we might say like, this is V, and that maps to, what, 9? We know that that's IV is 4. Then IX is what, 9? That's a for sure mapping. Then we do like a final sum say final sum minus equals Roman Roman to mmap, and we'll just say like, because it's what is it called? It's cur, right? Cur. I'll say dot join. Dot join what? Initerable. Is that legal? Can I do that? Oh, oops. So this should solve this case, right? Let's walk through it. So let's walk through it. Okay. So in this case, final sum is 0, pointer is at 0. I didn't increment the pointer. Okay. So cur gets what? I as a string, and then next then gets +1, so I again. Then we say if next equal to I or V, which it's not, else Well, that's stupid. Oh, my phone went off. While well, no, that's not gonna work, right? Because oh shit. Oh, that was a bug too. Damn, so funny. So while pointer, because the +1 will give an error. So how do we add this stuff? Because so in this case, right? If we have to look at each character. So I, right? And if we use a for loop, we have to know what the next character is to know how to move it. And if we use a while loop, we have to look at each character anyway. So in both cases, we have to look at each character using a while loop or a for loop. With a for loop, you might want to skip ahead, maybe, right? I don't know. That's the weird part. So if I look at cur, which is I, next is I, and pointer is now at 1, and final sum is at 1. PTR got incremented to 1 now. So now cur is looking at this, it's still I, we get 2. Pointer gets incremented to 2, which is still less than the length. But now, I mean, we could do a, we can do another if statement. So don't look at next if we are at length -1. Because we want the last one, but we don't care about the next. It'll ought to be taken care of, right? If PTR, we only care about next if pointer is less than length of S -1. That's all we really care about, right? So in some cases, next R won't be set, possibly unbound. So we only have a next if pointer less than the length. So length is 3. Yeah. So pointer now is safe. This is a safety check, basically, is what I'm saying. Yeah. So this is a safety check. And then right? This is fun. Oops. Oh, oops. Key error V. Oh, I don't have V in the mapping. Oh, it runs all the tests. Oh. I can't just run one of them. I can delete this, right? So for this test case, it passes. Okay, cool. It's a form for adding a test case. Cool. Okay, I can reset them and add them again. Okay, so this solves the first problem. Now we didn't have V as a mapping, so it didn't exist. So we got to map V out as well. So we're still moving forward. So it told us test told us we got to map out V. That's a 5. And what else in the next test case? We got to map out V. We got to map out L. And L is what, 50? Is a number. And so we can have other combinations, right? We can have L and V. Is that a thing? No, it's not. Okay, case 2 failed. Output was 3. Why was the output 3? There should be how many additions in this case? The L, since the L, yeah, L is only subtracted if there's an X before it. So there should be 4 additions. Why did it skip? What is this? Oh. Five. Oh, so because the next one. So because the next. Oh, I'm an idiot. Okay, this was based on eyes only. This was based on eyes only. So our code needs to change. Okay, good. Our tests are making us write better code. This is good. This is good. This is good. This guy, I really need chapstick. Dude, where did I put that chapstick? I don't get it. Where did it go? Okay, good. So this is saying we had an I. If the next is an I. So we have to make a smarter if check here, smarter loop mechanism. And our inputs are fairly controlled, so if statements are okay here, I think. So if we get, if the next one's a V, we subtract it for some reason. Not smart. Not smart. We don't have to do that. Not smart. Okay, so we get an L, right? And then we get a V. Crazy. So V is 5. So we got, okay, so we did 5. We got the 5. Okay, got it. Interesting. So we never even added the, we never even added the L. That's so funny to me. Okay. So we really only care about checking the next if our current character. So we can make a more complicated if statement, right? We can say that, and it's actually a set of them, right? It's a couple of them. It's if, cur is equal to I. That's one check. We say if next, right? If cur is equal to I, and if the next one is V or X, subtract, else add. Okay. Same thing for X. But let's see if that includes the test case. No, it does not. Test case 1 fails. So if cur is equal to I, which it is, then we go if next R equal to V or next R equal to X, subtract. We don't get into here, right? So this is say print have I, and then I'll do another print hello in here. Good. So we get 3 have I's. Oh shit. Oh god, okay. My if block's gonna be crazy. So joined gets cur.join with next. It's funny because next can be none here, so you don't want to do that. If self dot. So my thought process here is that if we can actually just create the pairing and look it up, then we can just add the pairing. We don't have to do like manual subtraction. So I'm thinking that if we do something like look up the joined, which one has a chance to be possibly unknown? Oh, I shouldn't say none. I should say dot get, and we'll look up joined, else return right. So basically I'm saying if we have a joined, right, then final sum should just add the lookup. Oops. Well, it'll be in there for sure, but okay. Well, at this point, we know it's in there. 0 is a valid pattern, but okay. So if the joined is valid, right? Although let's comment this out and put this else statement up there as well. Else, just add what's currently here. That worked for case 1. Didn't work for case 2. We should have gotten 58. LVII. Right? I like to use .get because I'm cool. All right, so our test cases are, this one's passing for some reason. So I'm saying we get L, next gets V, if, and join gets LV. LV is not in our list, so we return none. I should say not equal to none. Okay, so L, it's cur, next is none, join is none. We say L, then we check to see pointer less than it. Okay, at this point, yes. It's a valid, we can in a valid way get next. That way we make L and V. If dot get L and V, return none. So if not equal to none, otherwise final sum gets plus equal L. Okay, and L is 50. V then would be V and I. VI doesn't exist, so just add V. Let's print cur here. So cur is just I. What? Whoa. Oh, because joined. What? My code is fucked. My code is fucked, and I'm bad at this still. So let's look at the solution, because I have 40 seconds left, and I don't know what I'm doing. It's called commitment. It's called dedication. I can just reset it now, because this is ridiculous. Okay, I didn't get it. Solution. This discussion, let's look at this. Okay. In a lot of countries, blah, blah, blah. Okay. Ask, don't ever assume without asking, real interview input has to be valid. Okay. Is there one valid representation each number? There is more relevant. This is more relevant to the other question, integer to Roman. However, we'll still briefly look at it now. Given that the representation for 3 is I, it could seem natural that the representation for 15 is VVV, because that would be 55 plus 5. However, it's actually XV, right? It's 10 minus 5, which is actually 10 plus 5, sorry, x plus 5. How are you supposed to even know which is correct? The trick is to use the biggest symbols you can, because x is bigger than v, we should use x first and then make up the remainder with using a single v. We'll talk more about Roman integer article. This question is a lot simpler because there's only one logical way of converting from Roman numeral to integer. This is why the question should be a little bit easy, whereas the other label is medium. A few more examples. If you're not familiar with the Roman numerals, work through these examples and then have another go writing your own algorithm before reading the rest of the solution article. What is x? What is cxv I as integer? Okay. Recall that C is 100, X 10, V 5, I is 1. Because symbols are ordered from most significant to least, we can simply add the symbols. C plus X plus V plus I, so that's 117. Okay, cool. So going through some problems here makes sense to me, right? Adding them makes sense. Let's look at the approach. Left to right pass. Let's hard code a mapping with the value of each symbol so we can easily look them up. M through I. Let's recall that each symbol adds its own value, except for when a smaller value symbol is before a larger value symbol. In those cases, instead, subtract the large from the small, adding that instead. Therefore, the simplest algorithm is to use a pointer to scan through the string. At each stop, deciding whether to add current symbol for one place, or two places if we added. Oh yeah. Difference, or at the difference of the next two symbols and go for two places. Here's an algorithm, pseudocode. So we'd say something like while we have total, while I less than s dot length, if at least two symbols remaining, and value of s minus, and the value of, so we look up in some kind of mapping, right? The first one and the second one, then we first add the total, a subtraction of the smaller value from the larger value, then add that. And we increment I plus 2 because we looked at a pairing of 2. Otherwise, just add it and add it by 1. That's the simplest solution in pseudocode. Okay, so I'm not going to look at the actual solution. I'm going to try to replicate this solution in my own words. Okay. Let's delete all this. Okay. Total's probably good. Total's a probably good number. Now that I look at it. So they create a mapping of I. They did top to bottom. Who cares? I, V, L. What else is there? Physical solution works well. So there's I, there's V, there's L. There's I, V, X, which is mapped to 10, right? L 50, C is 100. Then there's D for 500. Then there's M for 1,000. And the pseudocode, something like this. Roman to int mapping. I like especially with code completion, verbosity is your best friend here. And they typed everything for us. Oh, look at this typing stuff for us. So test cases. So we're gonna say something like this, right? So while I less than s dot length. So while pointer less than s dot length, I guess s dot length of s. Right? We'd say if at least two symbols remain. So how do you check for two symbols remaining? So we should say if pointer less than length of s if pointer is less than length of s minus 2 or minus 1. That's when we have at least two. No, at least two remaining. What does that mean? Like two, like this one and the next one. Yeah. And what? And the value of s less than the value. Okay. So if we have two remaining, and the self dot mapping of s at ptr is less than of s at ptr plus 1, then we know what. So this is the case of the before and after, right? Then we know that we're going to do a total plus total gets total plus, let me put in parentheses here, right? Self dot Rome mapping of s at ptr minus self dot Rome mapping of s at ptr plus 1. Then we make ptr plus equals 2. We jump 2, right? In the else statement, it basically says it's the same thing. The else statement is total plus equals self dot at s of ptr. Okay. I'm gonna do ptr plus equals 1. That's invalid. .get returns none by default, but adding none to a number doesn't make sense. So you should specify, like, we get back there. And it failed case 3. Why did it fail case 3? So we said, what do we say? It says m, c before m is a subtraction. So we should do an addition, a subtraction, an addition, and subtraction. What's that? So addition 1, subtraction 1, addition 2, addition 3, subtraction 2. It's a sub. Right? Just see what? 2 addition, 2 subtractions. Okay, why did that one go wrong? Well, nothing, no errors, so I don't think this pointer thing is wrong. And it said self dot if. I mean, this probably should have done itself, but maybe it didn't. That's good. It's a self dot. I'm just mapping s at pointer less than. So for example, if we have if I less than me, right? That's the comparison we're basically making here. We're saying that if next we occur self dot as that pointer, occur next, it's dictionary key. Oh, we rarely do that, but okay. So you're gonna by saying if you occur is less than occur. So if PTR so if pointer, if there's still 2 valid characters and the cur is less than cur.next. Ooh. Oh shit. Smell good. I get it. This is the most brute force solution, but there's only one that. And if I thought it would iterate over probably more than that, but I don't know. I'm searching. Okay, so I went back and I'm coding this up. It didn't work for the last one. Weird. So it added 100, 100, 100. Is that even valid? MCM? What? Oh, it's a typo. I was like, what? Still wrong. 6. Wait, what? 1, 5, 10, 50, 100, 500. Okay. So we added 1,000, 100 minus 1,000. Not even less now. Thousand. Oh shit. The bigger one. I'm an idiot. There we go. Oh, I'm sad. Cool. Okay. So what was the well, there's another problem called integer to Roman, which is actually a medium problem, which is a little bit harder than this one. And the idea is that, well, we know we have to do something differently in a handful of cases, and really boil down to one check, which is if the current value is less than that of the next one, then we know that we have some sort of subtraction before we add, right? But I didn't walk through not walking through the next one kind of fucked me over a little bit. Yeah, not walking through so walking through more solutions might help, but coming up with one test case is good too. But you want to keep track of things that are coming up in the problem. So as you solve more test cases, yeah, that took me a lot longer than it should have though, and I'm tired. Wow. Okay. Yeah, I'm just do the one. Fuck it. I should come back though. Should I come back and do more? I'm exhausted. I need to eat, and like I need to find fucking chapstick. My lips are so chapped, bro. I mean, I have cocoa butter. Is that gonna work? Cocoa butter? It's a little aggressive. Anyway, that's it. I'm done for now.